Okay, so I'm going to do a few examples on rationalizing radicals in the denominator, and that's just a very complicated way of saying no radicals in the denominator. I equate this to like capitalizing the first letter of a sentence. You just don't want to leave things like this 2 over square root of 7. And the way you tackle this is you're going to multiply top and bottom by whatever square root's on the bottom. So in this case, I'm going to multiply top and bottom like this by square root of 7. Because square root of 7 over square root of 7 is 1. I'm not changing the value, I'm just changing how it looks. So when I multiply the numerators, I get 2 over square root of 7. And when I multiply the denominator, I get square root of 7 times square root of 7, which is just 7. So that's rationalized. Another example, 5 over 2 square roots of 5. Well, the problem is not the 2, it's this radical 5. So I'm going to multiply top and bottom by radical 5. Top is 5, radical 5 over 2 times 5, because radical 5 times radical 5 is 5. And then I notice these 5s would probably cross off, and that would give me square root of 5 over 2. Another style is square root of a fraction. And in this case, I can rewrite that as square root of 7 over square root of 4. And if I'm watching square root of 4, I can simplify just 2. So I get square root of 7 over 2, and there's nothing to rationalize. It's all done. So no square roots in the bottom, no square roots of fractions. It's just not done. Now, tougher ones. Yeah, that should work. So here my original problem would be 3 over 2 plus square root of 6. Well, I mentioned in class the conjugate of something like 2 plus square root of 6 is 2 minus the square root of 6. So if I want to get rid of this radical, I have to multiply by the conjugate when they get more complicated. So top and bottom by 2 minus square root of 6. On top, I'm not going to multiply the 3 in. I'll explain why in a second. And on the bottom, I'll FOIL these together. And whenever I do, the middle terms will go away. So I get 2 times 2 is 4. I get square root of 6 minus square root of 6. Well, that's just 6. So 4 minus 6 is minus 2. The reason I don't multiply this 3 in is because if this was divisible by 2, then I could simplify this further. So I always leave it right there. Another example. Scroll this up a little bit. Put that down. Negative 5 over 1 minus square root of 6. So the conjugate of 1 minus square root of 6 is 1 plus square root of 6. Again, the numerators I just put in front, negative 5 times. The bottom, FOIL it out. You're going to get 1 minus 6, and that'll become negative 5. And here the negative 5 will divide off. I'm left with 1 plus square root of 6. Okay, so this one is even more complicated. I have a bunch of radicals on the bottom, radical on top. The numerator is irrelevant here as far as being an issue. Though at the bottom, I have to take care of both these radicals, so I'm going to multiply by the conjugate of square root of 2 plus square root of 5, which is square root of 2 minus square root of 5. So the next steps will reflect this. I multiply by the conjugate. On top, it's going to look like this. Next step will be FOILed out. The bottom, when I FOIL that, square root of 2 gives me 2. I'm going to get square root of 10 minus square root of 10. They're gone. Square root of 5 times negative square root of 5 is minus 5. So that simplifies on the bottom to a negative 3. And on top, when you FOIL it out, you're going to get that. And I should look at each one of these radicals and think, can I simplify it? Is there any numbers I can divide into these I can take square roots of? And the answer is no. So let's simplify completely. And that's it for this video.